Hi, this is Andrea.
Matt,
And Ryan.
and this is us jumping into our project.
This is our data table, which shows the correlation between time in seconds and distance in yards when running from 0 to 100 yards. And then this is the graph that goes with it, and it came out to be a cubic regression with our data points, and the time in seconds is represented on the x-axis while the distance in yards is represented on the y-axis. And as you can see, as time increases, the distance increases as well.
Here we see the velocity graph. The equation is a quadratic regression reflected over the x-axis.
Y prime equals negative 0.09 x squared plus 1.28x plus 4.41. We got this equation by doing the derivative of the position versus time graph. As you can see, the graph is a negative parabola, indicating that the runner increases speed until reaching the maximum velocity, at which point he begins to decrease in speed. This is the acceleration graph. The equation found here is y prime double prime equals negative 0.18x plus 1.28, which represents the linear regression. This equation was found by taking the derivative of the velocity equation mentioned earlier. The graph appears to have an overall negative trend. While starting at the positive value, the graph decreases downward. This indicates that the runner started out at x speed and then experienced negative acceleration.
The instantaneous velocity is 18.33 miles per hour. We got this value by looking at the value of y of the maximum of the velocity graph. We converted this value from yards to seconds into miles per hour. The x value of the maximum represents at what second the instantaneous velocity occurred. At 7.111 seconds, the instantaneous velocity occurred. We confirmed this value by determining the value of 0 on the acceleration graph. We plugged in 7.111 for x into our position time graph equation to determine what yard the instantaneous velocity occurred. Our instantaneous velocity occurred at 66.34 yards.